demonstrate the worksheet 6 for you. So now in this worksheet, you will apply the Heron's formula. So as the Heron's formula is, if you know three sides of the triangle, then you can apply the area of ABC will be like this, and where S is the perimeter, A plus B plus C over 2. And it's quite trouble, but you can use the formulas free in calculator. Okay, once we know this free value, you can input from the calculator in formula free, then you get the answer in display. You show it S is equal to something, and this value will be the area. Okay, it's a little bit different from our book because S is the perimeter over 2, but in calculator, the value of S is, that means the area of the triangle. So I will demonstrate for you one by one for question number 1. So we know that three sides of the triangle is this three, so we can apply this Heron's formula. Is S is equal to the perimeter 5 plus x plus 11 over 2, which is equal to 12, and then the area. So the area of triangle ABC is square root is 12 times 12 minus A, and 12 minus B, and 12 minus C. And by calculator, you can get the answer is 18.3 cm squared. Okay, it is more convenient for you to just write down the value, write down the step, and jump to conclusion by the calculator. Okay. So for part 2, so it's question number 2. So in this figure, we always know the three sides of the triangle. So find the area of it is not difficult. So S is equal to the perimeter, which is equal to over 2, which is equal to 15. And then, so the area of triangle ABC, which is equal to apply the Heron's formula. And then you will get is 39.69 cm squared, as the question asks. Requirement is 2 dp. So we finished part A, and for part B, okay, find the height of H in ABC. So if this one is height, then which one is the base? Is the perpendicular side of this one, so BC is the base. Therefore, I can write down if H is the height of triangle ABC, then BC is the base. And therefore, we can write down the formula is the height times the base over 2 is equal to the area of the triangle. And after you solve it, you can get H is equal to 9.92 and 2 decimal places. Okay, so in this question, you have learned the concept is if this is the height, then this is the base. If here is the height, then this one is the base. And last one, if this one is the height, okay, and therefore this one is the base. Okay, so there are, in each triangle we have 3 heights and 3 different space. Okay, so for question number 3, so in the figure, find the area of x, y, z and the value of h. So for part A, the area of triangle x, y, z is not difficult, which should be by Heron's formula, you can get 36 cm squared quickly. And second one, so if this time xq is the height, then xy is the base. Okay, if h is the height of triangle xyz, okay, then zy is the base. So therefore, you can apply the area of the triangle, the height times the base over 2 is equal to 36. So after solve it, you can get h is equal to h. Okay, so h is equal to 8. Okay, so for question number 4, so in the figures, there are in ABC, we know the 3 sides of the ABC, so you can find the area easily. And the diagonal of AC is the angle bisector of BCD. So angle bisector, that means AC is angle bisector of BCD. So these two angles are the same. So for the first part, find ACD. Okay. So if we know ABCA, so I will get the answer because the AC is the angle bisector. So first of all, it will be related to another formula to find triangle, which we will use is 1/2 times A times B times sine theta, right? So first of all, I need to find the area first. So the area of triangle ABC, which should be equal to the S is equal to 6 plus 8 plus 12 over 2, which is equal to 13, right? 26 over 2, yeah. And then the area should be square root S times S minus A times S minus B times S minus C. And therefore, you will get this 13, and then 13 minus 6, 13 minus 8, and 13 minus 12. And therefore, you will get the answer should be, so wait a moment, it's like this, it's 13 times 7 times 5 times 1. And so the area should be 21.33072901. And once you get the area, then you can apply the sine formula. You can get, so 1/2 times A should be 6 times B 12, and sine of angle BCA, which should be equal to 21.33072901. Okay, this is the sine formula to find the area of triangle. And after you solve it, so the angle of ACB is equal to 36.3 degrees. And so you will get this. Therefore, angle ACD is equal to 36.3 degrees also. So we finished the first part. And for second part, find the area of ABCD. So we finished the first one, area of ABC. We need to find the area of 2. Okay, so for part B, the area of ACD. As we know the angle of ACD, so it's easy to apply the sine formula is 1/2 times 10 times 12 times sine 36.3 degrees. And you will get this 35 something. So the area of ABCD, which add these two areas together, so which should be equal to 56.9 cm square. So for 1 decimal places. Okay, so that's the end of question number 4. And now for question number 5. So in the figures, the perimeter of ABC is 48. So for part A, Heron's formula. So as we know, the S is equal to perimeter over 2, right? So which should be equal to 48 over 2, which is equal to 24. And secondly, BC is equal to 48 minus 17 minus 10, which is equal to 21. So we can apply the Heron's formula is the area of triangle ABC is square root 24 times 24 minus 17, and so on. And you will get the answer is equal to 84 cm square. So the first part. And for the second part is the shortest distance between A and BC is greater than X cm. So for part B, so where is the shortest distance is if A to BC, it should be a perpendicular distance. Okay, so that means it's the height of the triangle with BC the base. So therefore, we can let H be the height or the shortest distance between A and BC. So therefore, we can H times BC is equal to 2 over 2 equal to 84. And therefore, h is equal to 8. And so the statement is correct. Okay, so it's between is the shortest is greater than 8, so it's no. It should be equal to 8. Okay, so we finish the question number 5. So for question number 6, it's a little bit long. So in figures, BCD is a obtuse angle. That means it's greater than 90 degrees. Okay. So for the first part is BCD. So in AB is 31 and some information which is shown in the figures. So first part is find BCD. Okay, so first time I will join a line from BD. So how can I find the angle BCD? This one, right? So first part I will try to find out something. This one is the first step. I will find BD. And for second step, I will find the angle DBA. And then for the third part, once I get a pair of line and angles, and I will get the final part is our target. So I will divide this question into 4 parts. So for the first one, in triangle ADB, I can apply the cosine formula. So BD square is equal to AD square plus AB square. So you can do it by calculator. And then you can get the answer is like this. So you substitute a suitable value in it. So you'll get this BD is 35 something. So I can save it in the place A. This is the first part. And for second part, I need to find the angle. So because I can get the pair of the angles, right? So I can get the pair of this one. So for part 2, I will apply the sine formula as sine angle DAB over DB is equal to sine angle DBA over 8D because we know a pair of it. So we substitute the angle and the length, which is equal to the sine DBA over 28. So you will get angle DBA is equal to 49 something. Okay, so this is the second part. I save it in B. So for the third part, I will just use 69 degrees to minus our second part answer. So angle DBC is equal to angle, and you will get it 69 degrees minus 49 something. So you will get the answer is 19 degrees. So I save it in C. So this is the third part. Okay, the last part, as we know the pair of it was 60 to our answer 3, and the DB we know it by part 1, and so we can get the angle DCB. So for the last part, part 4, I will apply the sine formula. So sine angle BCD over BD equal to sine CD. Okay, so this is the C for CBD is the value of part 3, and for CD is 16, right? So it's not, and BD is the answer on part 1, so it's not difficult to solve angle BCD. And remember, we have 2 values. One is 49 something or 130 degrees. Okay, so which one should be suitable answer is still, remember the BCD is an obtuse angle, so it should be greater than 90 degrees. So in this time we need to reject this one because angle BCD is greater than 90 degrees. So the answer is here. So I save it in part C. and you need to write down the conclusion is so angle BCD is equal to 131 degrees and correspond to 3 significant figures. Okay, so for part B, find the area of quadrilateral ABCD. So for the first part, we can consist of two area. So first one is area of triangle ADB, so which should be easy. You can apply a Heron's formula or a side formula anyway. So you can get this answer. So for part B, so and then in triangle DCB, okay, so as we cannot find three sides or two sides with an angle between them, so you need to find the sides of it. That means you need to find BC first, or find the angle CDB first. Okay, so either one of it. Okay, so I can write down for angle CDB, because we know that angle 3 and 4, so I can find the angle of CDB. Okay, this is not difficult to find it, which is minus angle DCB minus angle CBD, and therefore you can guess the angle is 29 something. Okay, I've saved it in E. So finally, the area of BCD, which should equal to 1/2 times CD times sine CDB, and you will get 138 point something. So you just add up these two area, you can get the area of quadrilateral. So it should be equal to 556 point something, and for 3 significant figures. So that's the end of worksheet 6, and I will show you question number 7 in other video.